Beautiful auroras, which are ribbons of brilliant lights dancing about in the sky close to the north and south magnetic poles, emerge when the sun blasts a packet of energetic particles our way. On occasion, however, a hazy, enigmatic auroral light patch hovers over the North Pole. Given that they have appeared when the sun has been inactive, it hasn't been known what these lights are or what is producing them. Solar winds whipped through the ionosphere in a massive storm that dumped electric precipitation high above the North Pole. Satellites passing over the region experienced disruptions as a result of the unanticipated changes in the geomagnetic field, which occurred over a period of several hours. The world below continued to function, oblivious to the turbulent events taking place at the edge of space. A space hurricane is a real phenomenon, despite the fact that it sounds like the perfect setup for your upcoming science fiction Netflix binge. Scientists had speculated that such high atmospheric meteorology might be conceivable, but they now have evidence that hurricanes can occur at various altitudes in the Earth's atmosphere. According to a report in Nature Communications from February 2021, researchers saw and recorded the first phenomenon of its kind, which they called a space hurricane. The study's lead author, Qinghe Zhang of Shandong University in China, has been searching through satellite data with his students for intriguing upper atmospheric phenomena for a few years. One such data set was provided by the Defense Meteorological Satellite Program, which was established by the United States in the 1960s to monitor global weather patterns and aid in the planning of military operations. Zhang explains that since hurricane-like objects can be found on Earth as well as in the clouds of Jupiter, Saturn, Uranus, and Neptune, such as Jupiter's Great Red Spot, he was interested in whether a similar object could be found in the planet's upper atmospheres. The satellite encircled Earth seemed like a good place to start looking. On August 20, 2014, military satellites observed an auroral spot spinning directly atop the North Magnetic Pole that resembled a hurricane. However, the solar activity at the time was completely inappropriate. Strong auroras were not possible due to the alignment of the Sun's extended magnetic field, and the solar wind, the Sun's stream of charged particles and magnetism, moved slowly and contained few energetic particles. At a later date, it was proven that such a phenomenon was caused by the space hurricane. But what is a space hurricane exactly? It is useful to understand what causes space hurricanes and how similar they are to the lower atmospheric hurricanes we are more familiar with, because they have probably happened before in the history of our planet and will likely happen again. The first known space hurricane was observed on August 20, 2014, according to research done by a group of international scientists. For nearly 8 hours, high in the upper atmosphere, a spiral of plasma that was more than 600 miles (1,000 kilometers) across swirled above the magnetic North Pole. Although it was not visible to the human eye, weather satellites were impacted and alerted scientists of the activity. According to meteorologist Brian Loder, who specializes in astronomy and space coverage, like many space weather phenomena, charged particles from the Sun interacted with Earth's magnetic field to spark the space hurricane. Because of the way it spins, which is similar to a tropical cyclone, this phenomenon is likely referred to as a hurricane, says Loder. He was a little surprised that they didn't call it a space vortex to match the popular weather term polar vortex, given that it was observed over the North Pole. Space hurricanes and Earth hurricanes must be related since they have the same name, right? They do, in fact, share some characteristics, but they also differ greatly. Space hurricanes and Earth hurricanes are similar in another significant way besides shape. Both have an eye at the center and on bands of storm activity, in that they both have precipitation. Although the aurora produced by this particular space hurricane may have gone unnoticed by people on the ground as it occurred during the summer in the northern hemisphere, the worst time of the year to look for aurora since the days far outlast the nights, says Loder, hurricanes that we are familiar with have liquid precipitation, rain, while space hurricanes have electric precipitation that can create stunning aurora. We're hoping the next one will take place in the winter so we can see the show. However, there is another significant distinction between the two types of hurricanes. The two take place in entirely different regions of the Earth's atmosphere, says Loder. The space hurricane was observed in the ionosphere, which extends anywhere from 50 to 600 miles 80 to 966 kilometers above Earth's surface, whereas normal hurricanes occur in the troposphere, the part of the Earth's atmosphere that is closest to the ground and rises upward of about 5 to 9 miles 8 to 14 kilometers. The hurricane in space was also enormous compared to a hurricane on Earth. At more than 600 miles wide, it was roughly twice as wide as the average hurricane in the troposphere. Then why did this space hurricane occur? Scientists are still unsure, however, some theories exist. The primary one relates to the electromagnetic conditions in 2014. According to the research published in an article, August was a month of low solar and otherwise low geomagnetic activity, while the Sun was at the peak of its most recent 11-year cycle. According to senior meteorologist and astronomy blogger David Samuel, this low ionosphere activity was probably comparable to the hurricane-conducive conditions that contribute to hurricanes on Earth. Samuel remarks, "It seems to happen when things are quiet. This reminds me of hurricanes, very little geomagnetic activity, low solar wind. Hurricanes need light winds aloft, so thunderstorms can form and rotate around a center without the strong winds aloft pulling them away from the center," Samuel continues. As the center forms, the thunderstorms grow stronger and stronger, spinning faster around it until powerful winds in the upper atmosphere tear them apart. The space hurricane most likely formed when the right set of high atmospheric conditions came together and then dissipated when those conditions changed. Loder claims that while it's possible that one of these storms could affect Earth, they are generally harmless. If there are enough charged particles raining down from space, a space hurricane could potentially cause some disruptions on the ground. In addition to creating aurora, it could disrupt GPS signals, radio waves, and in extreme cases, the power grid, says Loder. However, given the sparse population of the polar region, if this event only affected the poles, the number of power outages would be constrained. Scientists will undoubtedly be attempting to ascertain where and how frequently space hurricanes occur after having discovered this first one. However, compared to their counterparts on Earth, it's likely that we don't need to worry too much about them. The next solar maximum will most likely take place in July 2025, though scientists are unsure when the next space hurricane will occur. Although the Sun's cycles are much more flexible than our earthly time systems, which are based on the Sun, it's possible that the next space hurricane won't be detected by scientists until after it has already occurred. This could lead to similar conditions for another space hurricane. But who knows, maybe when you see an unusual aurora light next winter, it might very well be the new space hurricane. Did this catch your interest? Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.